Hello, everybody, and welcome to We Measure the World, a podcast produced by scientists for scientists.
We all live and die by soil, literally. I think we just have to remind people that it's about your quality of life. It's about the food that you eat. It's about the safety and welfare of your children. Start there.
That's a small taste of what we have in store for you today.
We Measure the World explores interesting environmental research trends, how scientists are solving research issues, and what tools are helping them better understand measurements across the entire soil-plant atmosphere continuum.
Today's guest, Dr. Cristine Morgan, is widely recognized as one of the premier soil scientists in the U.S. and is currently serving as the Chief Scientific Officer at the Soil Health Institute in North Carolina. She was formerly a professor of soil science at Texas A&M University, where she received numerous awards for teaching and research. She has served on the board of directors for the Soil Science Society of America, is editor-in-chief for the global soil science journal Geoderma, and founding editor of the journal Soil Security. Dr. Morgan received her bachelor's in plant and environmental soil sciences from Texas A&M University and her master's and doctorate in soil science from the University of Wisconsin-Madison. Today, she's here to talk to us about soil health and the impact that it has on us as a society. So, Cristine, thank you so much for being here.
Thank you. Happy to be here.
All right. So first, we wanted to start off just by getting a little bit of your background. What got you interested in science in general, and then more specifically, soil science?
Well, I've always been interested in science. My parents are both scientists, but they're biological scientists, and I always thought that science wasn't going to be my gig. It was going to be law school. So I started out at Texas A&M University, prepared to go to law school, but I figured that since I wasn't so great at taking tests, that I would get a science degree and that would help me get into law school a lot easier. And after the first semester, chemistry, taking the basic science classes, I did pretty well. And I was bragging to my brother, who was older than me. So, there's always sibling rivalry. I was just bragging about how well I did. And he said that I did so well because I didn't take any hard classes. And so I just remember that Christmas looking him in the eye and saying, "Tell me the hardest class you took." And he said it was this introductory soil science class taught by Murray Milford. And so I said, okay. And I went back and I changed my schedule and I added that class to my spring semester. I took that soil science class and I fell in love. My parents were scientists. My mother's a plant scientist, my father an entomologist. I just thought I knew everything there was about science. To this day, I always tease my grad students and people I engaged with that you don't find soil science finds you. And I think it's actually the case because nobody knows about soil science.
Right.
But I just love the fact that if you liked physics, if you liked chemistry, if you liked biology, there's something to study in soil science. So you could still do the hardcore science, but then also apply it to something that's just so relevant to life on Earth.
Was there any interest then in going the direction of environmental law?
I wanted to run the EPA.
Oh, really?
Yeah,
Okay.
that was I don't know why. I had just decided that the EPA was waiting for me. But yeah, and that's actually why I went into soil physics, because I was just so interested in water, clean water, what happened when water fell on the ground, where did it go and what did it do and how did it make friends? And that just totally intrigued me, and that ended up being what I did study in my PhD, was just what happens to water when it hits the ground.
So as an undergrad, we've heard that you got into soil judging and
Yes.
soil judging team there. How did that happen? First of all, for those of us who might not know what soil judging is, can you explain a little bit that and then how you got interested in that?
Yeah, soil judging is originally a very uniquely American thing, by the way. I think it came from 4-H, FFA, these ag schools, and the idea that, you were training future farmers. It's a thing where you go out and you go to a place and you study the landscapes and how the soils formed on the landscape, and they dig pits and you walk into the, these little divots into the ground and you look at the soil profiles and you have to describe what you see, and then you have to make interpretations that are appropriate for building homes, farming, and just figure out what that soil is best used for. And that's what you're graded on. So I thought it was a joke, to be honest. When I changed my major, Tom Hallmark, who was the advisor, said, well, we have this thing called soil judging. And I'm looking around going, are you kidding me? What is that? How nerdy and backward and agriculturally can you get? And but then I went out and I did it. I thought, oh my gosh, this is so much fun. And you get to miss school for a whole week. You get to travel somewhere and get dirty. I mean, oh my gosh, I loved it. In fact, when I came back to Texas A&M as faculty, after Tom Hallmark retired, I became the coach. My Australian counterpart and I ran the first international soil judging contest.
Oh, wow.
And the thing about that was so interesting is that we brought together soil scientists, faculty, that, at one time in their life, like me, they had fallen in love with soils by looking at soils in the field. But they had become scientists that worked behind computers and in labs with dried ground soils. But it was so amazing to see that spark. We were actually teaching them how to be coaches of soil judging, how to play the game, right? Here's the game, here are the rules, this is how you do it. It was really reinvigorating. As faculty at A&M, I taught a lot of field soil science, but it was really something to take people out that were my age, older, later in their careers, and just see that spark happen again. When we did the international contest, it was like all the faculty became 25 years old again. We had a great time being soil nerds, doing this weird thing.
You mentioned Tom Hallmark as the faculty advisor to that team. How else did he help you in your early studies as a mentor and other things?
He taught me soil science. Like, as I have traveled around the world and met many pedologists, which a pedologist is someone who studies soil, I realized that I think I got the best world-class training in identifying and describing soils across landscapes. I had no idea how lucky I was to have someone like that teach me. But the other thing that he did is he was my undergraduate mentor, and then I went off to graduate school. And when I came back to Texas A&M, he was my faculty mentor. And it was very interesting because there's not a lot of women in soil science. And when I started my career in 2004, I was the only female tenure track faculty at Texas A&M in soil and crop sciences. Tom really helped me understand the culture of going into a science where men were my peers. Like, of course, I'd always been a student, but it was different becoming faculty. And he really was that friend that taught me the cultural norms so that I could thrive.
So from then, you said you moved on to Wisconsin, University of Wisconsin-Madison. Can you tell us a little bit about your experience there, working with Dr. John Norman and your research there?
So when I was an undergraduate, I was really good in chemistry. And so I thought if I went to graduate school, I better pick something that I was bad in so that I could get better at it. So I chose soil physics. Also, it had to do a lot with water movement. I was so intimidated and so frightened of being a soil physicist. Like, what is that, right? Like, the physics word is a very intimidating word. I couldn't have picked a better mentor to, push me through that path and make me take classes that I had never thought that I was capable of doing. But John is also very interesting. He taught me a philosophy of science that I think that not everybody gets. He taught me that the hard problems were the fun ones to go after and not to be scared of them. And so I thought there was a way to do science, right? The scientific method, and that you do these steps and these steps and these steps. And I remember one time I was trying to understand something and John's like, well, I think you've read enough papers about it. Let's not read too many more papers. He said, when you get an idea and you're interested in something, you need to read the papers to know what other people have done. He said, but you don't need to read so many papers to think that what other people have done was the right way to do it.
Right.
And so he always pushed that in me. I think that made me a different kind of soil scientist than I probably would have been under, any other kind of mentoring. And hopefully I did the same for my students as well. Learning how to be uncomfortable was something that I learned a lot in graduate school. How to be unsure, not know the answers, not be afraid to investigate something just because you don't know how to investigate it, and just kind of be a bit intrepid. Of course, we could also talk about all the biophysical equations that I learned and
Right,
how to
yeah.
solve for them.
How's your math now,
Yeah,
right?
I loved it. I loved it. I was always just amazed in biophysics in general, how, you know, there's things that you observe, and then there's an equation that describes that observation. And then you play with the equation, and all it's doing is like reinforcing what you've already touched, felt, or smelt. I found that so liberating. I remember I was taking biophysics, and I was riding my bike into school, and I was thinking about the boundary layers and all the and the wind, and I thought, oh my gosh, I could calculate that if I wanted to. That was so empowering. So I think probably this idea that to investigate something you don't understand, but how empowering it is to be able to write an equation and describe something that you observe. Wow. You know, that just makes you feel like you can do science.
Right, exactly. That idea that you can look around the natural world, like you said, there's something that can help describe or explain this phenomenon
There's
that I'm
math
seeing.
to it,
Right?
right?
Yeah.
And I'm not a good math person, but to see an equation and recognize, oh my gosh, that describes something. Like, you know, the fact that metal and styrofoam can be the same temperature but feel different.
Right. Yeah.
You know? And like, oh, I know how to calculate that feeling. Yeah. John Norman had us do these crazy equations. I remember one equation, he put an iceberg in Lake Mendota, and we were supposed to calculate, given the wind speed, how fast this iceberg was going to hit a pier.
Wow.
And I remember looking at that equation going, no way I'm smart enough to do that. And then I sat down and did it. And I was like, oh my gosh, I can do that. And you know, I never had to do anything quite like that in my science, but just knowing internally that I could do that just kind of gives you that ability to think, and it's just liberating.
All right. So along with that, can you tell us about your work with spectroscopy?
Yeah, soil spectroscopy. So that's another link between University of Wisconsin and even some people that are now employed at Meter. When I came to Texas A&M, one of the former student that I had gone to school with in Wisconsin, David Brown, and I had always talked about like going to the field. I'm a field soil scientist. I am not a lab soil scientist. I will get behind a computer and model, but first I have to be inspired with something out in the field. And what I was interested in doing is modeling water movement across the soil. Like, so here we come back to, I'm still interested what happens when the water hits the ground. One of the things is that these models need information. And so I really got into sensors and figuring out how we could use sensors in the field without pulling soil samples and bring them back to the lab, how we could get this information in the field. And that led me to spectroscopy. I would say I tenured on spectroscopy because that was my first project that I developed on my own at Texas A&M. And what I did different is that a lot of soil scientists were looking at pulling soil samples, bringing them to the lab, drying them, grinding them, preparing them, and then scanning them with visible and near-infrared spectroscopy. And I had zero interest in that. And I thought, if we can do it in the lab, why couldn't we do it in the field? And of course, everyone said, well, because the soil is not ground and because there's all these different water contents. And I had a friend, a colleague that was really pushing me to investigate this. And I thought, well, if I'm going to investigate it, I'm going to investigate it for something I would use it for. And I took it to the field. And my colleagues told me that I was crazy and that I was being too risky with my tenure. But I thought, you know what? If I don't get tenure because this doesn't work, then I don't want tenure. I want to go do something fun and useful. And so I did. My very first master's student and I took it to the field and we scanned soils outside in the raw. And it turned out that it worked. And then I ended up working with some colleagues that were really better at what they would call maths. Not math, but maths. They were at University of Sydney, and we found some neat algorithms where we could even erase the effect of water content and in situ-ness from infield scans. And I've worked on that ever since. You know, when you start a tenure track position, that they always say, get a 10-year goal. And my 10-year goal was to have an instrument that you could go out into the field and just push it straight into the ground and measure clay content and organic carbon. And I did it at 12 years.
Nice.
And I was so excited. And we patented it. And I actually still, at the Soil Health Institute, work on a project to get this thing to work for carbon markets. So I have never spent every year of my career working on it because, funding cycles go up and down. But it's always kind of been my baby and something that I know works. The real challenge is to get it commercial, which is something that, of course, Meter works on a lot.
Right,
but it's a trick. It's a trick to think about something that might could work. I mean, I think that's a skill set. Another huge skill set in science for me has been getting it to work in real life. And, I kind of did that as a scientist at Texas A&M. Like, okay, here's an idea. Let's see if we can come up with the experimental design to show that it works. And there's actually some art and science to that. But now I think what I am learning is, okay, yeah, so it works, but for it to be used, someone has to be able to pull it off the shelf. And that transition from proof of concept, it works, the stats are great, to getting it so that anybody could pull it off the shelf and read a user manual. Oh my gosh, that is not easy. I'm very lucky now at the Soil Health Institute to be around people that know how to do that. So that's kind of been a fun thing with leaving academia to engage more in the private sector with really, really brilliant minds.
Can you explain a little bit about the Soil Health Institute in general, its purposes, how it came to be, and then how you got involved with them at first?
Samuel Roberts Noble Foundation founded the Soil Health Institute with an original commitment to get it up and running, and the idea to safeguard and enhance the vitality and productivity of soils. The strategy for that was to develop a research agenda to bring soil scientists together to agree on things, on like, how do you measure soil health? How do we get those measurements into the commercial world and practically, because there's so many different ways to look at measure soil health. And that was kind of the foundational movement of the Institute. And when I joined, there was a project on that. And since I've joined, we do a lot of work with translating soil science knowledge, but also doing our own fundamental research. But it's all really focused on how do we get good soil science out of the scientific world and into that translational world where it's a tool that people use to better manage our resources.
And how did you get involved in soil health? So you've moved from wanting to be pre-law or law school into soil science, soil physics, and now soil health. How did that come to be?
In spectroscopy, I started developing a relationship with a couple of folks at University of Sydney. And one of them is Alex McBratney, who's a petametrician, which is another kind of soil scientist. I'm also considered a petametrician. And we were working on spectroscopy, but then we just started working on other things together. And one of the concepts that we started developing and talking about together was this idea of soil security. And soil security kind of has these 5 dimensions where we think about like what the soil is capable of doing, like its genetics, how the soil is managed, so the condition of the soil, how it's responding to anthropogenic activity. But then, and that's soil science, right? But then beyond that is, how do humans connect to soil? How does policy connect to soil? How does the economics connect to soil? And so the 5 dimensions are, the soil condition and the soil capacity, but then also the economics, the sociology, and the policy and the governance. And when I started kind of developing those ideas and trying to talk to people about it, I realized that soil science had really not done a good job of developing relationships with these other types of, there were a lot of one-off relationships, but not like a real body of knowledge. In doing that, I started working with a sociologist and an economist at Texas A&M University, and I had never really worked with farmers before. And so I started working with land managers and trying to understand how they think about soil. And I just got really passionate about it. And I probably was on my way of setting up a soil security institute at Texas A&M. But then the opportunity arose to work at the Soil Health Institute. And what I saw was this institute was this nonprofit research extension translational kind of unit. It was kind of like the vehicle was already built. It just needed a driver. And so I brought a lot of those soil security ideas to the Soil Health Institute. And that was really my interest, was just like, hey, 15 years, I've done a lot of work in science where I thought it was practical and thought it had a lot of application, but I had never really done a very good job of crossing that threshold into application. And so that was going to be my new challenge in life. I had met my 12-year goal or whatever,
right.
and soil security was that next goal. And I just decided that perhaps academia was not the vessel that I needed to be navigating.
Right. How would you then define a soil that is in good health? Is that from place to place? Is that from soil type to soil type? I mean, from a human, well-being perspective, we talk about our human health, divided up into our physical health, our social and emotional health, all those
even
kinds
our
of things.
Financial
even
health,
our
right?
financial health, and so we really need to look at, and I think we're kind of doing a better job now at looking at things holistically. Is that how you approach soil health as well? And how would you characterize soils that are in good health?
Honestly, when I started the Soil Health Institute, I heard this common criticism from soil scientists saying, well, we don't know what soil health is. And I thought, really? Because when you're healthy,
right?
Right? Like, why is this complicated? This is the way I think about it. A healthy soil has the highest capacity to function well, to do things that it needs to do, right? And in agriculture, it's growing biomass, but it's also providing those external ecosystem services to society, right? Cleaning our water, cycling nutrients, doing the things. I look at a soil and say, could this do a better job of what we're needing it to do for society? Every soil can be healthy, but there's kind of this world of soil science. They think about quality, and the soil quality world was about soils that can maximally produce something like agricultural kinds. So now you're thinking of these Midwestern, gorgeous, deep, lush, mollisols, we call them, soils that are so productive, right? And that's a high quality soil versus a soil in the tropics or in the southeastern United States. Maybe it's lower quality. I think the soil health kind of concept is a little bit different. We're like, well, that rich mollisol can be healthy, and this clapped out, weathered southeastern soil can also be very healthy. They are going to have different production capacities, and you're going to treat them differently, but they can both be healthy. And so when I think about measuring and assessing and monitoring soil health, it's a very place-based question. And that's pedology, right? So we're all the way back to my soil judging world, where you're looking across a landscape and understanding where the soils vary, why they vary, and what their different capabilities are. So I think it's kind of nice. It's all kind of circular, and it's the same in all of soil science. I think that's the beauty of soil science, is that, like earlier I said, there's chemistry, physics, and biology, but there's also place.
Right.
And that makes it complicated, but also makes it like alive and a challenge.
You've mentioned that there is this relationship between humans and the soil. What is then the impact on, I guess, both for good and bad, between soil with good health versus poor health? And how does that work with us?
Economically, if a soil is in poor health, we have to burn fossil fuels to create inputs to help that soil do what we need it to do. So that's more fertilizers, more weed control, more this, more that, more plowing, more that,
Right.
And so in my thinking is, when our soils are healthier, we don't have to put so much into them. And part of it is our time. We interviewed over 100 farmers in the Midwest, and we were looking at partial budget economics of these farmers that had successfully adopted soil health management practices. But the number one thing they kept saying at the beginning of the interviews is, since I've been practicing these practices, I have more time for birthday parties. I attend more graduations. I'm there with my children and my grandchildren. And I think that's soil health and human health right there, right? That there's not a lot of people, not a lot of farmers in our population, but there's some of the highest suicide rates. But if we can, if soil health makes them healthier and enjoying their life more, my gosh, that's a great soil health, human health story.
Right.
But also it's economics. We've shown that farmers that practice these soil health practices on average are making about $50 more an acre. And it's just less inputs, less, and a lot of it's their time. So I think soil health equals human social health, human economic health, and of course our biophysical health, because we are relying on these soils to cleanse our environment, help us adapt to climate change, and ultimately grow our soil and give us water to drink. So it's pretty important. For my generation of soil science, soil scientists that come after me and soil scientists before me, much of the study that we've done on our agricultural soils are on degraded soils. And so one of the things that we have to think about is the soils that we think are normal are degraded.
Right.
And that normal is not healthy. And that is such a hard thing to think about. But when you see soils that are being managed well, after you've studied for so long soils that have been plowed and treated pretty roughly, it's even more inspiring because they're resilient and they're alive and they can improve. And I never really thought about that, but you think about farmers too. Farmers for 2 generations at least have farm degraded soils and they think that's normal. So these rich mollisols that are feeding us are actually degraded and they're still just performing wonderfully for us. Right? So it's just kind of this strange juxtaposition that we're in, is that we don't even recognize how degraded our soils are unless you're on marginal soils. And then you recognize it.
Right.
And I want to credit David Lamb, who's a soil scientist and one of our soil health trainers at the Institute, that pointed that out to me. And now it just sticks with me every time I look at a soil. It's like, is this normal? Should this be normal? Is this what it should be looking like?
What are some of the best ways or best practices, methods that you've found to measure soil health? What are the criteria that you look for in a soil with good health?
Yeah, so that was one of the very first questions that the Soil Health Institute has tried to answer. So we embarked on this project that we affectionately call NAPSHM, which is a strange acronym, but it's the North American Project to Evaluate Soil Health Measurements, NAPSHM. And we looked at 124 long-term research sites. So they had controls and treatments of soil management in Canada, the United States, and Mexico. And what we did is we went and sampled all of these soils in the spring before agricultural management started happening on them. And we measured over like 30 soil health and soil characteristics. And we looked at those measurements. We've recently published, I think we have 5 papers that are being published right now in the peer-reviewed literature that provides information on how we evaluated that. And then we have another paper that is actually in my email that I need to review and get out. And it's more of a synthesis paper where we're going to recommend for measuring and monitoring soil health at scale. So I'm talking about across the 300 million acres of agricultural soil, that we need to measure soil carbon concentration, aggregate stability, and this potential carbon mineralization, which is like a 24-hour incubation test where we look at respiration from the soil. And that those 3 things really cover indicators for water cycling, carbon cycling, and nutrient cycling. They don't cover everything. And certainly if you were to study soils, you might want to measure more things. But just a very minimal set of things that you can measure and get the physical, chemical, and biological health indicators of the soil. But the important thing is that those are 3 simple indicators. One, you can measure with your smartphone, so that's kind of cool. And if I have my way, 2, 3, all 3 you'll be able to measure with your smartphone in the next 5 years. But I think the other important thing to remember about that is even though we have these 3 simple measurements, farmers, crop consultants, agronomists are still going to make these measurements and then ask, how do I know this soil is healthy? And that's kind of where we're embarking now. And it's a big initiative at the Soil Health Institute and of mine. You know, we start talking about those 10-year goals, right? So my next 10-year goal is to develop for the United States and perhaps for the rest of the world is this concept of soil health targets, where we group soils into where we think they have similar soil health potential. And then we measure them at different management states so that we have brackets of like how degraded the soil can look, how healthy it can look, so that a farmer could go and take their measurements and kind of track their soil health and know, maybe like on another iPhone app where you click, I've measured my soil, now what? Here's the GPS. Oh, this is how healthy your soil is today, and this is how healthy your soil could be. How cool would that be?
That would be super cool.
Maybe my 12-year goal is that all those measurements can be made with your phone, and then maybe we'll do a 15-year goal that you could evaluate those measurements with your phone.
What other initiatives do you have going on besides this North American project?
Well, we have a really cool project right now. We're calling it the U.S. Regenerative Cotton Fund. Is founded by Ralph Lauren Corporate Foundation, and they are they have made a $5 million commitment over the next 5 years to get this fund started, where we're working with cotton farmers and we're working with education on soil health for their locally relevant soil health practices, doing the economics so they could see what the costs and benefits are of adoption, and then also the soil health targets concept for these cotton soils across the cotton belt of the United States. So that's a really exciting thing where we're at Soil Health Institute. We've done economics, we're working on targets, we've done training, and now we're able to pull it all together in this comprehensive package to hopefully move the needle. And we're working with other groups. I think we had a press release today that VF Foundation has joined the fund. And we're hoping that others will be interested in joining the fund and moving the needle and working together. We feel like we're like that technical end to help, in the cotton space, the retailers and brands to meet their goals and help farmers become, healthier, right? Help farming become healthier. Right. And of course, I'm a soil junkie. And at the end of the day, I tell everybody, I can talk about farmers, I can talk about sustainability goals, I can talk about carbon, but really what I'm interested in is soil. And so I tell everybody I have a conflict of interest that I'm really just interested in the soil at the end of the day. But I think that we can all come together and think about what we think is important. And honestly, that is why I'm a soil scientist, because I think that pretty much everybody, whether they know it or not, have a fundamental interest in healthier soils.
So you talked about some of the organizations that you've been collaborating with. Are there others that the Soil Health Institute are working with on other projects?
Yeah. So with the Cotton Project, we work with Cotton Incorporated, which is kind of the R&D arm of cotton commodity. We work with extension, state extension specialists, extension agents, trying to get them information they need and resources they need to do their job, and also get information from them that we can help also understand and disseminate. But other larger partners, we work with Truterra, the conservation arm of Land of Lakes and Winfield United, and I think they touch roughly half of the corn growing acres in the United States. It's a nice federation of crop consultants. And so we're really working with them with the targets concept, I'm trying to understand, what the business case is for that ag consultant to understand soil health. But specifically, we have a project right now with Truterra. Truterra has sold carbon credits to Microsoft. I think it's the only one in the United States that Microsoft has been engaged in. And so we're kind of that engine to help with the sampling strategy and the quantification of those carbon credits. So that's a partnership. It's a lot of fun. Again, I love that partnership because, first of all, the people at Truterra are smart and they're creative and they're focused and they are farmer-centric. And, so I'm a soil scientist, our team are soil scientists, and there's this beautiful tension of wanting to do we all want to do good science, but they've got to take it to scale.
Right.
And that is such a challenge, and it's so invigorating. And I say my best ideas have come in the last 2 years working with Truterra and just going, how fast? What? No, we have to do it this way. Okay, maybe we could do it that way. You know, it's been very invigorating. So that's been a great partnership. Yeah, we work with McCain's potatoes. And so we've kind of moved off into Canada with Canadian and American cotton potato farmers. That's a challenge. I don't know much about potatoes, but I'm learning. Another really big project that we have is with DMI, which is Dairy Management, Inc. Our project is funded by FAR and also a bunch of dairy retailers. It's called the Dairy Soil and Water Regeneration Project. Okay. And so we're working on dairy farmers, and it's part of DMI's greater net zero initiative. And so we're working with dairy farmers at the farm gate, at the farm field, trying to figure out what are the management practices that we can use both in dealing with the manure and then dealing with the soil health to optimize water quality, and of course with the net zero initiative, soil health and soil carbon sequestration. So that's also a huge learning curve, like taking soil science out to the dairy and working with ARS and with agricultural land grants with this project. So it is continental. Right. It is so challenging to do things at the continental scale and at this business scale. But I think that's where science is. I think that's where ag science is right now. Like, we need to be challenged. We need to get out there and translate what we know.
I think along with that, so you talked about your transition from academia into the private sector. What are some of the things that academia does well when it comes to soil science, and what are some of the things that maybe the private sector might be more beneficial for?
Well, academia is very set up for the fundamental, knowledge search, right? The fundamental research. The other thing, academia is we're training the future. I miss that. I miss that so much. I miss interacting with the 18 to 25-year-old group because they're so elastic and they're so creative and they're so confounding some days. But I do. So I think academic institutions, they're training our future. They're doing the fundamental research. And it's just a breeding ground for some really intelligent people getting really well trained. So I think that's what academia does very, very well. I think my interest, as I've stated before at the Soil Health Institute, is the translation. I just saw so much happening around soil science and soil management, and there were no soil scientists present. And I just thought, I need to be there. I want to be there. Someone's got to be there. Okay, it's me. Let's go. And so I think that's where I felt very hindered being an academic, that I couldn't be there, that the reward system, I was not going to be rewarded for being at the table trying to inform decision making. That, the reward in academia is the publication and the grant and the training the students and, that component. But I was really finding myself wanting to agree, I'll be at that round table. I'll be the soil scientist there. I'll try to get our knowledge translated and out there. And so, I just thought, okay, I think in the nonprofit world and in the business world, of course, in the business world, it's all about scaling the knowledge, right, and making it applicable. And I think in the nonprofit world, it's about being at the table and trying to help folks. We publish papers, actually. It is our goal to continue to publish in the peer-reviewed literature so that we have that credibility that our decisions are supported by science. But certainly, our number one goal is impact. And that's been interesting, is like, how do you quantify impact, right? And that's a different game than it was in academia as well.
Right. Oftentimes, there's this disconnect between scientists in general and the public at large. What are some ways that soil scientists might be able to be more productive in translating their work and sharing that with the public, helping promote, adoption of best practices, especially when it comes to soil health?
One of the things that I have done that's been successful is just sharing my enthusiasm. That gets people asking questions and interested because they're like, why are you so interested in dirt? But on a more complicated and a more thoughtful level, what I have learned to do is dig deep. I'm an empathetic person, which I think helps in my communication. But I've also learned from my work with a sociologist and with my graduate student, Diana Bagnall, who did a lot of sociology of science translation. You've got to think about who are you talking to and what's important for them. Mm-hmm. What do they want to know? When I'm talking to a farmer, I don't necessarily talk about like all the geeky soil stuff. Mm-hmm. Well, sometimes I do. Mm-hmm. But ultimately what I want to say to that farmer is like, you change your practices, your soil will be able to capture 2 more inches of water for your crop, right? The farmer knows what to do with that information. Mm-hmm. Mm-hmm. And so, but it's not intuitive to us. In soils, we have our jargon, right? I want to talk about saturated hydraulic conductivity, but the farmer wants to know how many more inches of water am I going to capture? Mm-hmm. In soil science, sometimes when we talk about soil health, just to give an example, we want to talk about how much more yield you'll get. But there are so many factors that go into yield. That's not where we want to communicate. That's not where we should be communicating. I cannot guarantee a farmer more yield, but I can guarantee a farmer 2 more inches of water. And I'm going to let the farmer do what the farmer needs to do with that information. And so I think that's the same when we're talking to nonprofits. How do we quantify environmental equity with improvement in soil health, right? They want to know, how am I improving environmental equity for this group of people that I'm concerned about? How am I going to improve the water quality of the water that goes into the Mississippi River? And so when you're a soil scientist or whatever science, you got to get out of your jargon, you got to get out of your head, and you go, okay, today I'm talking to Walmart Foundation. What does Walmart Foundation care about? Clean water. How can I articulate my goal, as I've always said, is I love soil and I'm a geek, but I can't go in and talk to Walmart Foundation about how I love soil. I've got to go and talk to Walmart Foundation about how better soil management improves water quality. Maybe when you're talking to a senator, you need to talk about how better soil health gets some more votes, because ultimately these days that seems to be what they're interested in, right? Mm-hmm. You just have to dig a little bit deeper, be a little bit empathetic, and just think almost transactionally. What does this person need to know? What nugget of information are they going to take home that they can make an actionable decision on? Mm-hmm. And so I hope that even though they're saying, Cristine, you're very enthusiastic, I hope that really they're saying is like, 2 inches of water. Right. I'm going to go think about that one.
Right. There's a lot of politicization of science in general. How can we avoid, politicizing soil science or even depoliticizing it as if it gets to that point?
Mm-hmm. Well, first thing I'm going to say is, if a politician, I have learned, decides to politicize something, they're going to be pretty effective at it. Mm. But what you can do is, again, think about who you're talking to and how they benefit. It's something that we all have to rely on, right? And usually governments deal with those kinds of things. Mm-hmm. The use and care of natural resources is generally a government conversation. Right. But on the other side of the politics of the government, why is it a government conversation? It's the tragedy of the commons, right? Mm-hmm. We all live and die by soil, literally. Mm-hmm. I think we just have to remind people that it's about your quality of life. It's about the food that you eat. It's about the safety and welfare of your children. Start there. And the amazing thing is, I can find the most politicized subject matter and talk to somebody who's on the other side of me, and I guarantee you will agree on 95% of that subject matter. It's the 5% that's polarizing, right? And so you just got to dig into that 95% and agree that there's a common goal, and then decide how you could work together towards that common goal. I mean, all statesmanship works that way. Right. And I think as a scientist, I would love to just say, I just stick to the facts. But, that's such a lazy approach. And it doesn't work. Mm-hmm. We know the facts don't always save us.
You had talked earlier about first getting into soil science and really seeing it as being a male-dominated specialty and field. It seems to be progressing a bit more away from that. What more can we do to help create need for more women in science or for other groups who are less represented?
Mentorship and role modeling. And, it's the same with farmers, getting farmers to adopt. Ultimately, it's a social question, right? And, just like when I talk to a farmer, when I want to incite a farmer to think about changing their practices to improve soil health, my best bet is finding a farmer that has done it and have that farmer do the talking for me. And I think it's the same way with, inclusion and getting underrepresented peoples into a science, is that you have to have them represented and you have to have those folks in leadership. So they have to see a path. And then, of course, it's not easy. I was just in a situation where I was on a judging panel. I was the only female. And we were judging a bunch of startups. One of these were great startups. One of them had more than one gender on their leadership and governance. And I just thought, oh my gosh, we still have a long way to go. But, as someone who was aware of that, and, I talked about it and I brought it up. And I think that those are the things, we just have to have those conversations. And I think we just have to role model. Like, for instance, one of the things we've done at the Soil Health Institute, I told you how I missed the 18 to 25 crowd. So we've started a summer intern program, and we recruit only from 1890 land grant institutions. And, we're learning. We're not perfect, but we're learning how to do it. And we're two of our interns from last year, we've hired, right? Because that's how you do it. Right. You find them. You have to look. And my point before with the one of the startup companies that had integrated, I was speaking to one of the people there, and I said, I noticed this about your leadership. And the gentleman said, thank you for recognizing that. We have worked hard. We have been purposeful in doing this. And I think that's the thing. When you're in an area where there's a group of people that are underrepresented, the leadership has to make a decision, and you have to be purposeful. It doesn't happen by default. It just doesn't, because we're humans. Right. It just doesn't. So anyway, I think it's changing. When I was at Texas A&M, when I started, I was the only female tenure track faculty. There's many now. And when I actually left Texas A&M, I was the balancer. But before I left, there were more women tenure track faculty in soil science than there were men. Wow. When I left, then it was 50-50 again. But, and that happened in 15 years. Right. But it was purposeful. Right. Yeah. I think that's part of it. It does need to be purposeful, or else, just the momentum, the inertia of previous years is just going to kind of keep that ball rolling. It's a silly story, but I remember when I was faculty, I was probably, 10 years in, and it was late at night, and I was walking down the hallway, and there was a female graduate student, and she said, hey, Dr. Morgan, I've always wanted to tell you something, and since no one's around, I'm going to tell you this. I said, hey, what's that? She goes, I think it is so wonderful to see a female scientist that likes to wear pretty shoes. And I said, well, I do like to wear pretty shoes. She goes, that just gives me joy because I don't feel so self-conscious when I want to wear pretty shoes. And I thought, oh my gosh, I never even thought about that, but there you go, right? Like there was a precedent, and she could see herself there. Right. Yeah. And so just because she liked pretty shoes, she could still be a scientist. How cool was that? Right. And of course, there's a million perturbations of that story. And that's what we need more of. I mean, you don't have to dress like you're going to the field every day, right? To be a soil scientist. Yeah, and I think that was her point. She's like, I like shoes, and I didn't know if that was socially acceptable. Right, yeah. Thank you for making that socially acceptable. Yeah. So what then does the future of soil health look like? The next generation of soil scientists study soils that are not degraded. That when a soil scientist walks across an agricultural field and they see a degraded soil, that's not normal. I think that would be cool. The other big component about soil health that I would like to see in the future is that anybody that eats food knows what soil is and recognizes that their food comes from soil. And I think that gets back to that soil security concept of connectivity, and that we just do a better job of relating to people the importance of soil in their life. We know more about space than we know about soil science. In my career, I have known 2 astrophysicists that have become soil scientists.
Really?
And they said that soil science is way harder.
Really?
You can't peer into the soil. And a lot of my work has been about developing sensors and tools and concepts and models to peer into the soil without digging it up.
Right. You talked about that connection between regular individuals and the food that they eat, that it goes back to the soil, right? What else can we do, maybe at community level or even, up to global scale, to promote soil health from our own sphere of influences?
I think the best way that we can influence, anybody can influence the improvement of how we treat our soils is A, minimize your consumption. Because soil is a natural resource and we are depending on all of our natural resources. And, the consumer society is something that worries me a little bit. And then the other thing is share your insights. When, you think about soil and food and where your food comes from and where your clean water comes from. Yeah, that's a hard one. Being an educator, I always go back to education, K through 12 education. And when I was at Texas A&M, all pre-COVID, I went into my kids' school. I always volunteered every year, science teacher. I could come in and talk about soil, and about half of them would take me up on it. And I even started a soil judging team with my daughter's 2nd grade class.
Really?
Oh, it was so cool.
Oh,
those
cute.
kids know how to get dirty.
Yeah. Right. Yeah.
Yes. Until you've seen 6 ponytail girls in rubber boots out in the field with clipboards, hand texturing soil, you haven't lived.
That's awesome.
I think sharing education and, you can always donate to the Soil Health Institute as well.
All right. Okay. All right. Thank you so much, Cristine, for taking time to share your passion and your projects with us. And if you in the audience have any questions about this topic or want to hear more, feel free to contact us at metergroup.com or reach out to us on Twitter at meter_ENV. And you can also view the full transcript from today in the podcast description.
Stay safe, and we'll see you next time on We Measure the World.